So good evening friends. I welcome you all for our second session of the second chapter of chemistry, that is introduction to analytical chemistry. Okay, so in first chapter in first session we have discussed about the introduction of analytical chemistry. I covered this complete part. Then we have also seen some of the important concepts of analytical chemistry, and that is importance of analytical chemistry. So wherein we have discussed about the various applications of this analytical chemistry. So after this we have seen what exactly this analysis is, what are its types. We have discussed about this qualitative and quantitative analysis also, and we have started the methods of qualitative and quantitative analysis, that is chemical method of qualitative analysis. We have finished, and I also discussed with you all about the chemical methods of quantitative analysis. Okay, and in last session we have started with mathematical operations and error analysis. Okay, so I will quickly revise what exactly this concept is. So we are going to start from this part. So what will happen when we discuss about mathematical operation and error analysis? the, the what we call is accuracy of the measurement is most important parameter in analytical chemistry, which is of great concern, we can say. Okay, so basically what will happen, there are various intrinsic errors, or what we call as in our simple language, there are various internal errors in the analytical measurement. Okay, so what will happen in mathematical operation, the numerical data which we got from experimentation. Okay, so we call it as iteration. If for just for any experiment we have taken 3 readings, so that is what we call as experimental data. Okay, so this experimental the numerical data which we get from experimentation, which is treated mathematically to each some quantitative to reach in order to reach some quantitative conclusion. Okay, so that is what we are doing. We are using two methods over here. So in first method we are doing, we are using numerical data which I got from experimentation, and I will cross check with some mathematical techniques. Okay, and based on this complete validation process, I have to draw one conclusion, I have to reach some quantitative conclusion. So that is what the numerical data and mathematical operation is important. Okay, hence analytical chemist, the one who knows the basic idea about analytical chemistry, we call it as an analytical chemist, has to know how to treat the quantitative analytical data which he got from experimentation as well as mathematical techniques, so which indicates the extent of accuracy of measurement. Based on that data we can say that how accurate the given data is. Okay, through its experimentation, through it is mathematical technique, and along with this he has to perform mathematical operations and properly express the quantitative error in the result. See, if there is a some mistake in providing error in the system, so there will be no accuracy, and there will be no accuracy in measurement, and it will of no use, we can say. Okay, so after this we are going to start some of the aspects related to measurement as well as calculation. Okay, so out of this first aspect we are going to discuss about scientific notations. So these scientific notations, we have to consider this complete scientific notations, which is also known as exponential notations. Okay, so this is very important while we solve the numericals, or while we express the any data which is having large digits. Okay, or more digits, more number of digits. See here, a chemical one example is given. A chemist has to deal with numbers. Always there are various numbers are there, and he has to deal with various numbers. So they may be large, as here one example is given. So here if you see, you will come to know. So in this example, 602200000 and something, one large number is given. Okay, so which is for what is the value of this number, or what that number indicates? It indicates the molecules of 2 gram of hydrogen gas. or as we all know, the mass of hydrogen atom is 0.000000 up to so many zeros are included, and 0.166 gram, that is the mass of hydrogen atom. Okay, so every time we have to write these zeros, whatever the number of zeros are there, so which is somewhat cumbersome, which is somewhat hectic in nature. Okay, so to avoid this, what we are doing, we so in order to replace these so many zeros, what we are doing in mathematical operations, scientific notations are used. Okay, or we called it as a exponential notations also. Okay, so there is a one standard format of these exponential notations. With the help of that format, any number can be represented by n into 10 raised to n. Okay, so where this capital N is what, this n is a number varying between 1 to 10. Okay, and small n is what, small n is exponent, which may be positive or negative. Okay, so we have to remember this, the number small n may be positive or negative, and capital N is varying from 1 to 10. Okay, so in order to express such complicated problems, or complicated, in order to avoid this number of zeros here, if you can say, so we can use this format n into 10 raised to n. Okay, so this we can write by considering this scientific notations. So that first number 6 point becomes 6.022 into 10 raised to 23. That is what, that is mass of. So instead of this, what I am writing, so instead of using such big number, I am going to replace with 6.022 into 10 raised to 23 only. Okay, so this is how n into 10 raised to n, where this n is 6.022, so n into 10 raised to n. So this format we have to use, 6.02 into 10 raised to 23. Small n is 23 in this case. Similarly, mass of hydrogen atom, instead of writing 0.00000 so many zeros and 166 gram, we can write this as a 1.66 into 10 raised to minus 24 gram, isn't it? So in this way we can write the mass of one hydrogen atom. Okay, so this is the way through which, while we are using exponential terms and we are writing down the numbers to avoid this hectic writing schedule of zero zeros. Okay, so similarly one more example is given here. You can see over here, this complete example, 1.23 123.456 becomes 1.235456 into 10 raised to 2. Okay, so means what we are doing in scientific notation, if you see generally, so if we shift the decimal towards the right, we have to subtract the power, isn't it? And if we shift the decimal towards the left, we have to add the power. So simple rule we have to consider, and write down the scientific notations. So most important thing is that while writing, we have moved the decimal to the left accordingly, as I already discussed. When we move towards the left, we add the power, and when we move towards the right, we subtract the power. Okay, so just have a quick look. So with the help of some examples, we are going to discuss about this. So let us start with this problem example, which is already given. So let's try to understand it. So question is like this: for adding 5.55 into 10 raised to 4 and 6.95 into 10 raised to 3. So these are the two numbers which I have to add. Okay, so if you see, what you will come to know, this first digit is having exponential term 10 raised to 4, and second digit having exponential 10 raised to 3. So in order to add them, one most important criteria is what, the power should be same, isn't it? So either first term should be 5.55 into 10 raised to minus 10 raised to 3, or second term should be 6.95 into 10 raised to 4. Similarly, either out of these two numbers, we have to convert that exponentials into, yes, into the same number, so that it will be, or we can say the exponent we have to make made equal, then we can add them. Okay, so what I did here, if you see, first number, I keep the first number 5.55 into 10 raised to 4 as it is, and in this second number, instead of 6.95, I will shift this decimal point towards the left. That becomes 0.695. When I will shift the decimal point towards the left, I have to add the power. So instead of 10 raised to 3, it becomes 10 raised to 4. Okay, now what will happen if you observe these two numbers? You will come to know power of both terms is equal, then you can add them, no problem. Okay, so 5.55 plus 6.095 into 10 raised to 4, because it is common term, this term is a common. Okay, and when we add this, it becomes 6.245 into 10 raised to 4. Okay, for addition or subtraction, we have to make the exponents exponential. We have to, first step is what? First make exponent is made equal, then we can add or subtract. Okay, so in example number 2, let us start with this example. The subtraction of two number, this example is based on subtraction. Okay, so the subtraction of two numbers can be done as shown in figure. So here are two numbers are given. First one is 3.5 into 10 raised to minus 2, and second one is 5.8 into 10 raised to minus 3. Okay, as I already told you, first exponent is made equal. So this becomes 3.5 into 10 raised to minus 2 as it is. So instead of 5.8, what I am writing here, so instead of 5.8, I will write this as a 0.58. Okay, so and hence I shift the point towards left, so I have to add the power. Okay, so if I will add this power, minus 3 plus 1, so it becomes minus 2, isn't it? So that is the reason I put here minus 2. Okay, so now exponent is equal 10 raised to minus 2. You can common out this exponent and you can subtract it. You will get your answer as a 2.92 into 10 raised to minus 2. Okay, so this, in this way you can add or subtract. Okay, so here if you see, the decimal has to move 4 places to the right. That becomes 10 raised to minus 4 in the exponent in the given scientific notation. Okay, so after this we are going to discuss about some of the operations, mathematical operations on the numbers which are already expressed in the scientific notations. Okay, so what will happen after this, we can say that use of scientific notation or use of exponential notation will help us to avoid the to save our time and to avoid the unnecessary writing of zeros. Okay, so after this example, let us start with this example, that is 2.3. Here multiplication of two numbers is there. Okay, first one is 5.6 into 10 raised to 5, and second one is 6.9 into 10 raised to 8. Okay, so as we all know, when multiplication is there, we have to add the power. So similarly, it is very easy, basic thing is there. So 5.6 into 10 raised to 9 into 10 raised to 5 plus 8, it becomes 10 raised to 13, and product what I will get is, here I will get this product. So this is how we can say that 38.64 into 10 raised to 3. Okay, again you can also change the answer 3. Likewise, if I will shift this point towards left, I have to add one power. So 3.846864 into 10 raised to 14. Okay, so this is how you will get your answer. Similarly, one more example is there in case of multiplication. First 9.8 into 10 raised to minus 2 is there, and we have to consider second number as 2.5 into 10 raised to minus 6. Okay, again we have to add the power. Minus 2 minus 6 becomes minus 8, isn't it? And 9.8 into 2.5 becomes 24.50 into 10 raised to minus 8. Okay, or you can also write 2.45 into 10 raised to minus 7. Okay, so in this way you can see that you can easily solve the problems with the help of scientific notations. They will definitely, when you will use scientific notation, it will definitely save your time. Okay, and you will get the accurate answer. Most important thing is what? There should be minimum chances of creating or our producing error in the system, and we will get accuracy in the measurement. That is what the purpose of scientific notations, or what we called it as a exponential notations. Okay, So after this we are going to discuss about, so I think I have covered this addition and multiplication, isn't it, with the help of these examples indirectly. Now after this we will start with the most important parameter of the chemistry, that is precision and accuracy of the measurement. So actually most of the time student will get confused in precision and accuracy of the measurement. So let us start with this. See, as we all know, aim of the any measurement, when we are measuring or where we are doing measurement, aim is what? To get the actual value, or that is what we called as true value, isn't it? So what we think, we should always get the actual value in our measurement, or that is what we call as true value. Okay, it's also known as accepted value of the quantity. Okay, so now what about accuracy? How we are going to define the accuracy? Accuracy is nothing but the nearness of that measured value to the true value. Okay, suppose for example here I'm writing true value is, let us say, 10.25. okay, and after measurement what I will get? 10.238. okay, so what exactly the accuracy is? How this measured quantity is near to this true value or actual value. Okay, so this is what the accuracy is. Okay, so after this, as we all know, larger the accuracy, smaller is the error. Means there is a more accurate answer, there will be less chances of error. And accuracy is most important parameter in any measurement, and accuracy is completely depend on the sensitivity, or what is called as least count of the instrument which we are using. Okay, and now the question arises here is, what exactly this least count is? Okay, basically least count is nothing but the smallest dimension that can be measured by that instrument, or that the smallest value that will give by the instrument. Okay, so here I will give you an example through which it will be easier for you to understand. So let us say one scale is there. Okay, so I am just drawing, and here starting from 0 centimeter, so 1 2 3 4 5, so let us say this is 1 centimeter. 1 2 3 4 5, now total this will be 1 centimeter. Okay, this is not 1 centimeter, this is 0.5, actually this is 1 centimeter. Okay, and likewise you will get up to 30 centimeter. Okay, so what will happen if you consider this scale, you will come to know here this complete 1 centimeter smallest value is what? 1 mm, isn't it? So this is the smallest value. Below this I can't measure, so this is how we called it as a list count. Okay, यालाच आपण इसी को हम list count भी बोलते हैं. So in list count is nothing but the smallest quantity that can be measured by that particular instrument. Okay, means with the help of that instrument we cannot measure the quantity which is less than the list count. Okay, so this is how the list count is, and accuracy is completely depend on the list count of the measuring instrument. Okay, so here I'm giving one example. If you see these three diagrams, you will come to know. So I'm discussing about these three diagrams. Okay, so which is also mentioned as three possibilities of burette reading, which is 10.2 ml. Okay, so here if you see in these all three example, a burette reading of 10.2 ml is indicated here. Okay, for all these three situations in the given figure, the reading would be noted as 10.2 ml, isn't it? This is also 10.2 ml, this is also 10.2, and this is also 10.2 as per as the diagram is given. Okay, what it means? It means that there is uncertainty about the digit appearing after the decimal point in the reading 10.2. Means what? Sometimes it may be possible that it is 10 point, it may be like this, it is 10 point, it must be 10.234, Okay, there is uncertainty after this digit 2. Hence we can say that there is always uncertainty about this digit appearing after the decimal point in the given reading, that is 10.2 ml. Why this happen? This is because the list count of the burette. If you see here, list count of the burette is 0.1 ml, means on this burette we cannot measure below this 0.1 ml. Okay, minimum dimension that can be measured on this burette is 0.1 ml, hence the list count is 0.1 ml. What is the meaning of the reading 10.2 ml? It means that the true value of the reading is always lies in between 10.1 ml and 10.3 ml. It is not accurate 10.2 ml every time. Okay, it may be less than 10.2, it may be 10.1, and if it is greater than 10.2, it may be 10.3. So means what, there is a always reading which you are measuring on the burette, it lies between 10.1 and 10.3. okay, this indicated by writing. So we can write this in this way. If you see 10.2 plus minus 0.1. okay, plus minus 0. Means is what, it may be 10.2 plus 0.1, that is 10.3, or it may be 10.2 minus 0.1, that is 10.1 ml. okay, here the burette reading has an error. We can say that the burette which we are using, which is having error of 0.1 ml. okay, so this is how the error measurement is carried out. okay, so after this, based on this example, we can say that what exactly the error is. okay, basically error is defined as it is the difference between measured value and true value. okay, and it is expressed as an error of n number of types. There are various types of error, but as per as your syllabus is concerned, we are going to discuss about two important errors. So out of which first one is absolute error and second one is relative error. okay, so these two errors are most important, which we are going to discuss. okay, now first started with this absolute error. So here if you see, you will come to know the exactly absolute error is what. It is nothing but observed value minus true value, or we can say observed value as a measured value. okay, which we are measuring. okay. Measured value minus true value is nothing but the absolute error. And what about relative error? Relative error is generally more useful quantity than absolute error. okay, see, because in relative error we are also considering the absolute error. If you see the formula, you will come to know relative error is nothing but the ratio of absolute error to the true value, and it is always expressed in percentage. So if you see this formula, you will come to know relative error is what, it is the ratio of absolute error to the true value. okay, means what, here that is the reason why we are considering the relative error is most useful quantity, because absolute error is already included. okay, hence relative error is most useful quantity than absolute error, and we are using this formula to calculate the relative error. okay, so here we have to use the absolute error upon true value into 100%, which because measurement and is this value is always expressed as a percentage. okay, so now there can be error in measurement. So when we are when we are doing measurement, there are n number of reasons because of which error is introduced in the measurement. So there can be many reasons. It may be possible that insufficiency of the person doing that, using that particular instrument, or there may be some error itself in the instrument, or there may be some atmospheric conditions. So there are various errors, various types of errors are there. We have to consider them one by one. Now we have seen that there are various reasons because of which error is introduced in the measurement. Now the question is that how we are going to minimize that error. The only solution, if I want to minimize the error, what I will do, I will take the multiple reading of the same quantity. So I have to measure it 3 times, 4 times, 5 times, what we call it as a iteration. okay, and based on that multiple readings, we can say that taking the average, we will get the accurate value, or we can say that when the accuracy is more, error will be minimum. okay, if the readings of the same quantity which we are taking again and again, they will match closely, that particular thing we called it as a high precision. Okay, high precision means what? It is nothing but the reproducibility of the readings. Means we are measuring, for example, I am measuring the temperature of the room where I'm sitting in. Okay, firstly if I will measure, it is observed that it is 37. Secondly, I will measure 37.1, 37.2, and if I will take the readings consecutive after 10 consecutive readings, I will get the repetitive number as 37.2. So 37.2 is nothing but the reproducibility of the reading. Every time if I am measuring, I will get the same reading. So that is what known as higher precision, or that is why we called it as a high precision. Okay, high precision is nothing but it is the prerequisite for high accuracy. Prerequisite means what? If I want to get the high accuracy, provided that it must be precise first. Okay, it is not like that it is not a precise and you will get accurate value. In order to get the accurate measurement, that value, that measurement process must be precise, then we will get the accurate value. Okay, so this is how they have mentioned here. If you see, you will come to know high precision is a prerequisite of high accuracy. Means if you have a high precision value, definitely you will get high accuracy. Okay, so precision is always expressed in terms of deviation. If you see here, you will come to know precision is always expressed in terms of deviation. In terms of deviation. Okay, again there are two types of deviation. First one is absolute deviation and second one is relative deviation. Okay, now let us start with what exactly the absolute deviation is. An absolute deviation is the modulus of difference between observed value and arithmetic mean. Okay, basically in our simple language we can say that absolute deviation is nothing but it is the difference between observed value and mean value, or measured value and mean value, for which we have to calculate the mean of the given data. Okay, and when we subtract that mean from the measured value, we will get the deviation, that is what we call as absolute deviation. Okay, here also they have mentioned the definition of absolute deviation mathematically. Absolute deviation is nothing but observed value minus mean value, or we also call it as a observed value minus or measured value minus mean. Okay, now here for which we have to calculate the mean. Now arithmetic mean of all the absolute deviation is called as mean absolute deviation. Firstly we have to find out the mean, and then we have to take the arithmetic mean of that all absolute deviations. Okay, and that is known as mean absolute deviation. Again, this concept is most important. We are going to discuss about all these concepts in the next question, that is in numerical 2.5. Okay, so first understand the theory concept, then we will start our numericals. So the ratio of mean absolute deviation to its arithmetic deviation is called as relative deviation, which is another type of deviation. Okay, so as we already discussed, there are two types of deviation. First one is absolute deviation and second one is relative deviation. Okay, so absolute deviation is nothing but measured value minus mean, and relative deviation is what? Mean absolute deviation upon mean into 100%. Okay, so this is how you will get the deviation, and deviation is what we always express precision in terms of deviation. Okay, so for which we need to know about two types of deviation, absolute deviation as well as relative deviation. With the help of these formulas you can easily calculate these values. Okay, absolute as well as a relative deviation. Okay, after this we are going to discuss about this numerical, which is most important. So if you read the numerical, you will come to know in the laboratory experiment 10 gram of potassium chlorate sample on the decomposition, after decomposition of that 10 gram of potassium chlorate, we will get the following data, out of which the sample contains 3.8 gram of oxygen. So here that particular sample gives 3.8 gram of oxygen, and the actual mass of oxygen in the given quantity of that particular compound, that is of potassium chlorate, it is observed that it is 3.92. Okay, so which is what? Which is true value. Okay, so we have to calculate absolute as well as relative error. Okay, so in order to calculate absolute as well as relative error, we have to use simple formula. For absolute error we have to use the observed value minus true value, isn't it? And if you see in our question, you will come to know observed value is what? It is 3.8 gram, because it is given in the laboratory experiment. In experiment we are always there is always importance to observation. So sample contains 3.8 gram of oxygen, means what? It is observed value or measured value. And what is true value? True value is 3.92, which is also given here. Okay, so according to formula we are using absolute error equal to observed value minus true value, and when we solve it we will get this answer 0.12 gram. Okay, so now this is about absolute error. Again we are using the next formula to get the relative error. So here if you see this formula which I already discussed with you all about this formula, that is absolute relative error equal to absolute error on true value into 100%. If you see absolute error is given, we have calculated in earlier steps, it is found to be 0.12 gram, isn't it? So it is also minus 0.12 gram, and true value is given, which is 3.92 into 100%. If you solve this completely, you will get this answer as a 3.06%. Okay, means there is a relative error of minus 3.06% and absolute error is of 0.12 gram. Okay, so this is how we are going to calculate absolute as well as relative error. So we are going to discuss further numericals in our next session. We'll stop here. Thank you.